This lesson is on math without a calculator, and specifically, this is for the multiple choice section of the AP Chemistry exam. There are no calculators allowed for the multiple choice section, and they do have problems that involve math. So this is just going to be some tips and tricks for how you can go about doing those problems. So what we want to do is make the math easy. And there's different techniques for doing that. So we're going to be looking at canceling, rounding, decimal fraction, scientific notation, and we won't always be putting things in proper scientific notation. We'll just be using this exponent notation to make our calculations easier. And the good news is that no significant figures are required for most of the multiple choice questions. Now, an exception to that would be if there was a question that was specifically about significant figures. Then fine, then you do have to do the sig figs for that particular question. But most questions that involve calculations, they might give you 5.0 liters. Well, for the multiple choice, you can just make that 5 liters. You will not have to worry about sig figs for most of the problems. Okay, so we're going to look at some examples. So first of all, we're going to look at this problem. So you have 33 times 18 times 400 divided by 3 times 9 times 10. Okay, so what you do not want to do is multiply 33 times 18 times 400, get a number, multiply 3 times 9 times 10, get a number, and then do long division. That takes way too much time. What we want to do is look for any place that we can simplify. So right here we have 33 and 3, so we can simplify that. 3 goes into 3, 1, 3 goes into 33, 11. Then we have 9 and 18, so we can simplify that. 9 goes into 9 once, 9 goes into 18 2 times. And then here, anytime we have zeros, we can cancel this 0, we cancel that 0, because that's dividing by 10, numerator and denominator. And then once you've done a lot of canceling, it's often a good idea to now write what's left so you don't get confused or make mistakes. So we have 11 times 2 times 40. And then our denominator is 1 times 1 times 1. So that's what we have. So here I'm going to say 11 times 2 is 22 times 4 times 10. So that is 88 times 10. I get 880 for my answer. So that is a lot quicker and easier than doing all that multiplication and then doing a long division. So always look at what you can cancel. Okay, let's look at if we have something like this, 299 divided by 3. Now, when we have something like this, we want to use some rounding to make this easier because we don't need to get an exact answer. It's multiple choice, so we just have to be able to pick the choice that's closest. So make this, turn that 299 into 300. So 300 over 3, our answer is 100. So if you do that on the calculator, it's going to be close to 100. This is good enough for the multiple choice questions. So look for rounding. So we could also have something like this. Say we have 32.05 divided by 7.98. Okay, so this 32.05, we're just going to make that a 32. 7.98, we're just going to make that an 8. 32 divided by 8 is 4. So that is much, much easier than doing that long division and keeping all those digits. Close enough, we're good. Okay, let's look at a type of calculation that you will be doing in AP Chemistry when we do thermodynamics. So something like 4 times 305 plus 2 times 199 minus 3 times 150 plus 439. And when we do something called bond energy, this is the type of equation that we will have. Multiple choice, we want to get a quick answer. So I'm going to change this to 4 times 300, that's close enough to 305, plus 2 times 199, I'm going to call that 200, minus, be very careful with these that you keep that minus, because this minus is for all of this. Keep these brackets here. All right, 3 times 15 is 45, so this is 450 plus 439, I'll call that 440, although I'm going to change that later. Okay, so now it's much simplified. So 4 times 3 is 12, plus our 2 zeros, plus 2 times 2 is 4, plus our 2 zeros, minus, so this is 450. I'm just going to round that to 450. You know what? Because it's close, and it's going to be easier, and I'll get an answer that is close enough. So 1200 and 400 is 1600, minus 450 and 450, 50, 50 is 100, plus 4, plus 4, so I get minus 900. So this gives me a value of 700, whatever units we have. So the answer key could show, and a lot of times it will show, maybe it'll have something close to that. I don't even know what this is. Maybe it's like 695. B might be negative 695. And then C might be 350. And D might be negative 350. So we've done a lot of rounding. This is what we get. Well, we're going to pick A. Be very careful about your signs. If these have been switched, it would be negative. Just be careful about your signs. But definitely between 695 and 350, our answer is A, which is a lot quicker than if we multiply these exact values. So use rounding. Okay, let's see. Oh, what another trick that can help is when you're given decimals to change them into fractions to do your calculations. So for example, if you have 0.5 in a calculation, well, 0.5, that's the same as a half. So that can be easier. If we have 0.25, you can write that as a fourth. And if you have 0.33, you can write that as a third. Of course, that's 0.333333, but good enough, close enough. 0.67, so you can write that as 2/3. 0.75, you can write that as 3/4. So here are some of the more common ones where it can be to your advantage to change this to a fraction to make the math easier, right? That's our goal, make the math easy. So for example, if we have 0.25 times 160, and now some people might be able to do this without just looking at it. Some people are just better at that than others, but others of you might be just like, ah, and you take 160 and then you multiply it by 0.25 and you do that whole calculation. No, forget that. That's too much time. 0.25 is 1/4. So we have 1/4 times 160. 4 goes into 4 once. 4 goes into 16 4 times. So our answer is 40. So it can be helpful to change those easy fractions, easy decimals into easy fractions. So let's look at another example where we could have something like that. So maybe we have 0.5 times 78 divided by 2. Okay, so I don't want to do 0.5 times 78. I'm going to make that a half. So that's 78. This is going to be a half. And then we still have this 2 down here. So this 2 is the 0.5. This is 1/2. Okay, so then we can just do 2 into 78. 2 goes into 7 3 times, and then 2 goes into 18 9 times. So we get 39 over 2. Now we're going to use our rounding trick. 39, well, that's a lot like 40. 40 over 2. Our answer then is very close to 20. You can do that on your calculator and see what you get. But that would be good enough for a multiple choice calculation. If we have something like this, 142 divided by 0.5. This is the same as 142 divided by a half. So now we want to get that 2 out of the denominator. So if we multiply this whole thing by 2 over 2, that's just multiplying by 1. 2 times a half, this cancels out. So our answer is just 142 times 2. 2 times 2 is 4. 2 times 4 is 8. 2 times 1 is 2. So there's our answer, 284. So for me, instead of doing a long division to figure out what this is, I just like this way better. I think it's a lot faster. Okay, so now we're going to look at some operations with scientific notation. So say we have 1.2 times 10 to the 8th times 4, oops, how'd that happen? Times 4 times 10 to the negative 3. So we just have to remember how to handle exponents. So we can go ahead and multiply our numbers. So 1.2 times 4, 4 times 1 is 4, so that's 4.8 times 10. And then to multiply powers of 10, we add the exponents. So we have 8 plus negative 3. 8 plus negative 3 is 5. So our answer, 4.8 times 10 to the 5th. Now let's say we had, I'll just use that same number. Let's say we had 4.8 times 10 to the 5th divided by 2 times 10 to the negative 3rd. This is a completely separate problem from up there, so I just use some of the same numbers. Okay, 4.8 divided by 2, so that is 2.4 times 10. Now our exponents, this is 5 minus a negative 3, and that's the same as 10 to 5 plus 3. So our answer is 2.4 times 10 to the 8th. So when we are dividing, we subtract our exponents. When we're multiplying, we add our exponents. Now here's the type of calculation that I have seen actually many a time on an AP free response. If we have the square root of 2.5 times 10 to the 15, and we got to figure that out without a calculator. All right, so the trick we're going to use for this is I know that 25 is a perfect square. So I'm going to write this number as 25 times 10 to the something. So this is equal to the square root of 25 times 10. Now, what is the 10 going to be? Well, if you're kind of nervous or whatever, and you're like, oh, I don't know what it is. It's either going to be 14 or 16. Which one is it going to be? Think of taking it out of scientific notation. So here I would have to go over 15. Here I'm starting one digit over, so I'm only going to have to go over 14. So it is 25 times 10 to the 14. If you take this out of scientific notation, take this out of scientific notation, you will have the same number. This is not proper scientific notation. Scientific notation, the mantissa, otherwise called a coefficient, has to be between 1 and 10. So it's not proper scientific notation, but who cares? We just need to get a quick answer to our square root. So the square root of 25 is 5 times, and the square root of 10 to the 14 is 10 to the 7th. And that's our answer, 5 times 10 to the 7th. And we can show that that is the correct answer because if we square this, we get 2.5 times 10 to the 15. So this is a really important little shortcut there. So again, we'll just do another quick one. If we had, say, 3.6 times 10 to the 9th, we want to write that so we have a perfect square. So that's the same as 36 times 10 going 9. Now we only have to go 8 times 10 to the 8th. So our answer, the square root of 36 is 6 times the square root of 10 to the 8th is 10 to the 4th. We divide our exponent by 2 when we're doing a square root of our exponent. So there you have it. That's, I think, a really great little trick there. All right, what are we going to do now? All right, let's look at this. We have 1200 over 0.003. And I'm going to show you 2 different ways to do this one. So we never want to have a decimal in our denominator. So I'm going to get rid of this decimal. So what I'm going to do, and I'm going to write this over here again so we can leave our original problem there. So what I'm going to do is move that decimal point over 3. 1, 2, 3. So that this becomes a 3. If I do that to the denominator, I need to do it to the numerator. So here's my decimal point. I need to move it over 3. 1, 2, 3. So now what I have is 1, 2, 0, 0, 0, 0, 0 over 3. So 3 goes into 3 once, 3 goes into 12, 4. So my answer is 400,000, 400,000. Now, another way to do this, sometimes it's a good idea to put things into exponent form, and that will also eliminate that decimal there. So another way to do this is I want this to be 12 over 3. So I'm going to write the top as 12 times 10 to the 2nd. That is equal to 1200. Then I'm going to write this in scientific notation as 3 times 10 to the negative 3rd. And again, to check, just take it out of scientific notation and make sure you got the number that you were trying to get. So negative 3, 1, 2, 3, that's it. All right, so now 3 goes into 12, 4 times 10. We are dividing, so we subtract. So 2 minus a minus 3 is 2 plus 3. We get 10 to the 5th. Well, these are equal. 4 times 10 to the 5th is 400,000. So putting things in exponent form can also be a handy way to get problems done quickly. Because on the AP exam, sometimes you can be pressed for time. Okay, so let's look at this one. 0.0000008 over 0.002. So again, we can do the moving the decimal point way. So 1, 2, 3 to get this to be a 2, and 1, 2, 3. So this would equal 0.008 over 2. So divide that, we get 0.004. Okay, we could also do that the exponent way. So we'll do it that way. We'll start with our original problem. So now we're going to put this in scientific notation to get that 8 by itself. So we have 8 times 10 to the 1, 2, 3, 4, 5, 6. So this is times 10 to the negative 6. And then our denominator, put that in scientific notation, 2 times 10 to the negative 3. 2 goes into 8 4 times 10. Negative 6 minus negative 3 is the same thing as -6 plus 3, which equals -3. So we get 4 times 10 to the -3, which is the same thing as 0.004. So either of these methods helps us get the answer quickly. So whichever one works better for you. Okay, let's take a look at a problem that you might have on a multiple choice question. So here's our problem. What is the pressure? I'm going to do a gas problem here. What is the pressure of 0.50 moles of gas at 27 degrees C in a 8.2 liter vessel? Okay, so multiple choice, we don't have our calculator, we got to figure out this without our calculator. So gas problem, we've got N, we've got T, we've got V for volume, we're looking for pressure P. So we're going to use PV equals NRT. And I'm looking for pressure, so I'm going to divide this side by volume, divide this side by volume. So I get P equals NRT over V. Substitute in my pressure, 0.5. I don't have to worry about sig figs. I'm not gonna, if this was a free response, I would absolutely have to write this as 0.50. Drives me crazy when students drop to 0 in free response. But in multiple choice, who cares? All right, so that's N or R, 0.08206. Okay, I'm just gonna 082, close enough to 0.08206. My temperature, of course, that has to be in Kelvin. So with 273, 3 and 7 is 10, carrier 1. So we have 300 Kelvin over 8.2 liters. So we've used all the right units, so we're okay with that. Now, a good thing to do is to look at the answers, because sometimes it'll be A, and you'll see this, B, it'll be this, except maybe they'll have 27 here instead of 300. So I've made the mistake personally where I've gone ahead and solved this, then look at the answer choices and see that I didn't have to do any math at all. So that would be a waste of time. So check the form the answers are in. So now if our answers are in atmospheres, in numbers, now we have to reduce this. So we're going to use some of those tricks. So here's this 0.5. I'm going to change that into a half. So 1/2, put that at the bottom. All right, and then we have 8.2 and 0.082. So I'm definitely going to be doing something with that. So this is 0.082 times 300 over 8.2. So from here to here, all I did was change that 0.5 to a half. Okay, so one of the things you can do, this is times 300. I can move this decimal point over 2 because that's dividing by 100, and move this decimal point forward 2 because that's multiplying by 100. So now I have 8.2 times 3 over 2 times 8.2. The 8.2's cancel out, so I have 3/2. So that's 1.5, and the unit would be atmospheres from the units there. Okay, so we used a couple of different tricks there, but this is very typical of problems I've seen on the multiple choice section for the AP Chemistry exam. Okay, let's look at another kind of problem that would be typical. Let's look at this one. How many moles in 300 grams of, I'll just use the formula, NaCl. All right, so we need to get molar mass for NaCl. So we'll do that. So Na, we have one of those. So our periodic table tells us 22.99. Well, forget that. That's a 23. Okay, we're going to round that to make it easier to get the molar mass. And our chlorine is 35.45. So I'm just going to call that a 35. Good enough. So 5 and 3 is 8. 2 and 3 is 5. I have 58. I'm going to round that to 60 grams per mole. So now to get the number of moles, so I have 300 grams times 1 mole is 60 grams. So now, this is easy now. Cancel out this 0, cancel out this 0. 6 goes into 35 times. So my answer is approximately 5 moles. And that will be usually good enough for use in a multiple choice problem. Okay, so again, let's just do another molar mass, see how we round that. So if we were doing the molar mass for silver nitrate, if this was for some other problem. So we have 1 silver, we have 1 nitrogen, and we have 3 oxygens. So silver periodic table tells us we're 107.87, so we can make that a 108. The nitrogen 14.01, make that a 14, and then oxygen 16. So this 108, you know what, I'm gonna make that 110 to make this even easier. Plus, I'm gonna make 14 into 15. I'm just gonna keep everything with 5s. And then 3 times 15, say, is 45. Just so I can really make this easy. 10, 4, 5, 6, 7, 1. Close enough for calculations that you'll need on the multiple choice section. Okay, so that's the end of my examples. So just remember, use canceling, use rounding, change things into scientific notation or some kind of exponent notation, if that helps you do the calculation. And for almost all the questions, you don't have to worry about the sig figs. You're just going to get a number that's close so that you'll be able to pick out the right answer from the multiple choices.